Yes, yeah, much more relevant.
Hello, there we go.
Yes. Well, actually, we started on like yes. I know. It'll be for the
Yeah. Yes.
or D, 1969? Nice. Question 5. What were the first living things to orbit the moon? Was it A, 2 monkeys, B, 1 gray rabbit, C, 2 Russian tortoises, or D, 42 mice? Caitlin, what kind of tortoise is Sheldon? All right, question 6.
How long will the Artemis 1 mission be? Will it be A, 2 months, B, 25.5 days, C, 3 years, or D, 5 days? It's pretty cool. Question 7. How much will the Earth's atmosphere slow Orion down during re-entry? Is it A, 325 miles an hour, B, 5,540 miles an hour, C, 24,675 miles an hour, or D, 1,230 miles an hour? You know this? All right. Question 8. How many parachutes does Orion have? Is it 1, A, 1, B, 0, C, 5, or D, 11? Oh, it's not 0. It's not 0, is it? Oh.
I know.
Well,
Let's hope they pack it.
is it a one-way trip or is it? Oh.
There's one even on it.
Oh, that's all right then. Question 9. The first moon landing missed the landing site by 4 miles. Is this true or false? And question 10. Is this the last question? Yes. Last question is, what year was the last crewed mission to the moon? Was it A, 2003, B, 2008, C, 1986, or D, 1972? Question 9 is, the first moon landing missed the landing site by 4 miles. Is this true or false?
Any other repeats?
Is it what's up?
Now they have to take the trivia sheets.
Oh. Please give your trivia sheets up to Caitlin. She'll come around and collect them. Oh, like co-hosts on Fox News or something like that. Sounds good. And we will be announcing the trivia answers at the end of the night. So please stay tuned. Is there a prize?
Yes.
There is a prize. Is it the socks?
Free
It is a free t-shirt
free.
or a free drink. Whatever you choose. I like the t-shirts. I think the t-shirts are pretty cool. Now it's what's up, is it? Yes. Now we're going to what's up with Yaswant.
What's up, everybody? So this is the month segment where we're talking about what's up in the sky, what to go observe, what's going to be up there, whether you have no equipment and you're just staring up at the sky after a night of drinking once many beers, or if you've got a nice set of binoculars or telescopes, here's some things to look out for. Number 1 is the Gemini meteor shower. This is going to be a pretty big one. It's one of the biggest meteor showers of the year. If you look at during the peak of the shower on December 13th, you can see up to 120 meters per hour. Well, you probably won't see 120 meters, but there's going to be 120 meters passing through the Earth around then. To find it, you should look in the direction of Gemini, hence the name Gemini meteor shower. That's roughly where they orient from. They're not coming from the constellation. The comet that they're coming from just happens to be like passing that part of the sky, and so we call it the Geminis. Anyway, look in the direction of Gemini. It should be rising in the east right around 10 p.m. And so you're going to want to find a dark side, get pretty comfortable, get a nice blanket, get a chair, get a six-pack or whatever, and just, chill out for the night. Unfortunately, the moon is 60% full, so it's going to drown out some of the meteor showers. But the moon won't rise until 11 p.m., so you'll get 1 full hour of dark skies to see all the meteors you want to see. The next big thing is there are a lot of fun asteroids to look at if you're interested in that kind of thing. They're all at opposition right now, which basically means that you can draw a straight line between the sun, the earth, and the object. And this is basically the best time to view these because they have full sunlight directly reflecting back at us. The first one on November 19th, well, November 19th is past, but it's still pretty bright, is 115 Lyra, which is best seen with the telescope near the constellation of Perseus. 325 Bamberga on November 22nd, which is, watched it recently. It is the 10th brightest object in the asteroid belt. You can't see with a pair of binoculars because it's so dang bright. Also near Perseus, not that far from 115 Lyra, so that's a fun one. And then 30 Urania is actually named the Greek muse astronomy. Didn't know we had our own muse. Unfortunate name for our muse. Best seen with the telescope, and it's somewhere between Perseus and Sirius. They're all roughly looking in the same region of the sky, which is pretty nice. So if you're looking to, get a telescope, get a really good pair of binoculars, use some fun things for you to go try and find. The final thing that I want to highlight is Betelgeuse, which is one of the brightest stars in the night sky. It's actually the brightest, if you can see the near infrared. It makes up the shoulder of Orion. Betelgeuse is a red supergiant. Its radius is actually larger than the asteroid belts. So this would be roughly where Betelgeuse would look like. You can't really see it over here, but this is basically, Earth is over here, I believe. This is the asteroid belt. Here's where Saturn, Jupiter, and like Pluto and stuff are. These are the plumes of Betelgeuse. And it's likely going to explode as a supernova sometime in the next 100,000 years. So, keep an eye for that. Some people got pretty excited because in 2020, it really got super, super dim. And people thought this was a sign it was going to explode soon. Everyone got really, really excited. Turns out, no, it's probably just dust clouds. But here's the thing. Now it's weirdly bright. No one really knows why. Some people think it's just being cranky and it has some sort of weird periodicity to its brightness that we didn't know about earlier. Maybe it'll explode again. There's this fun Twitter bot called Beetlebot that actually tracks its brightness and will tweet out how bright it is. So right now, as of yesterday, when I made this, it's 131% of its usual brightness. So who knows? Maybe it'll explode, maybe it won't. If it does explode, it's great for supernova scientists like me because that's going to be a really, really cool supernova to see. It's going to be terrible for most other scientists because it was so bright that it'll basically be really hard to observe a lot of other things in the sky. But it'll be fun for the rest of us because it'll basically be like there's like a second full moon that's up during the daytime somehow magically. So that'll be fun. And that, my friends, is what's up. Any questions? If not, then we are going to be taking a short 10-minute break. Make sure to, tip your bartenders, get some beers, talk to your astronomers, chat around. Make sure to ask Jacqueline about Magic the Gathering, which she's definitely an expert on. And yeah, we'll see you back in 10 minutes.
It's called the movie result, we don't have to go theory about that. With magnets, all right. What? Right. But you know, it's not like good.
All right, everyone, get back in your seats. We're starting up again. I hope everyone enjoyed their break and had a chance to go get a drink and obviously tip our lovely tenders. Next up, we have Nikko, who will be talking about in the news. So astronomy stuff that's been happening very recently. So everyone give Nikko a big round of applause.
I apparently don't get a fun fact.
Oh, sorry.
Wow. All right, what's fine? Fun fact about Frank is that ask him about his tattoos. All right. My mother is in the audience. Those are not unrelated statements. All right, so we've featured in the news for tonight. So starting off with story number one. This one didn't really come out in the headlines too much. I got like one notification from CNN about this story and then kind of dug into it. So at this place named the Museum of the Bible in Washington, D.C., there was this manuscript from some Christian text from about 1,000 years ago that looks like this. And some historical astronomers, that's a thing, people who study the history of astronomy. I was actually in the historical astronomy division of the American Astronomical Society, which means that I checked off one box and got their emails for 2 years. Thank you. So there was this document in the Museum of the Bible in Washington, D.C., and these historical astronomers did what is called multispectral imaging on this piece of paper, basically. And you can kind of see with no weird filters or anything that it looks like this text is written over other text. Okay, so you see like smudgy business going on back here, and then like the very obvious most recent text is the darkest black. And so this was a pretty common practice. A lot of old manuscripts were literally like scratched off and then written over because it's time consuming and annoying to make paper back in the day. So they did this thing called multispectral imaging, where in astronomy language, we call this photometry. Basically, it's just you take a picture and then you take a picture with a different filter, and you take a picture with a different filter. So here you kind of see things that are red, and you see things that are whatever this greenish color is. So if you take a bunch of different pictures with different colors, you can kind of tease out what the stuff behind this dark black lettering is. And so what I'm going to ask you to focus on, this might be hard on the projector, I'm going to ask you to focus on the red. And maybe, just maybe, like right here, I think is probably the clearest. So I'm going to blink back and forth between these slides a couple times. So you can almost see, I like to focus on this Y. I think that Y is pretty obvious. It's not actually a Y, it's just a thing that looks like a Y. But essentially, they teased this out. They did this imaging with different colors, and they came up with some text that looks like this. And what's incredible about this is it was determined that this was a catalog of stellar positions in the sky written by Hipparchus 2,100 years ago. And if you can't read this, this is what it says. Basically, it's saying, here's this group of stars, and it lies in this position in the sky, and it's next to this group of stars, which looks like this, and it rises, and it goes like that. That's basically what this whole thing is. And Hipparchus just listed out everything that he could see in the sky with his eye and said, I see this thing, and then I see this thing next to it, and then I see this thing next to it. So this is actually the oldest map of the stars that exists today. I think this is awesome. Yeah, this was purely just I thought this was cool, so I'm including it kind of story. Also, for those who are interested, this is at a place that's called the Museum of the Bible in Washington, DC. Would anybody like to guess what company the family who owns the Museum of the Bible also owns? My mother would be cheating. I told her this earlier today. Caitlin's also cheating. Yeah, the family who owns the Museum of the Bible also owns Hobby Lobby. So they own the oldest map of the stars as well. Going into our next segment, I usually have a little break in the middle where I do a bunch of highlights. This is actually going to correspond very nicely to some things that Yaswant was talking about some asteroids that are currently in opposition. And I'm basically just going to say, we're all going to die. Okay, moving on. Okay, to give this the 30 seconds of light it deserves. So some of the objects that Yaswant was talking about, these asteroids that are at opposition, which basically means that it's the best time to see them. Some of them are not necessarily on a collision course for the Earth, but one of them, I don't know which one of the three, is the largest near-Earth orbit object, or will be near-Earth orbit object that has been discovered in the last decade. So yeah, we're all gonna die. Every in the news has some existential crisis in it. Thank you, John.
We got dark now.
John is carrying my jokes.
I'm enjoying.
So our big story of the night, we heard a bunch about this in the news. Jesus, this is in the news. We heard a bunch about this in the trivia. We're going to talk a little bit about Artemis. So Artemis is carrying the Orion spacecraft. A bunch of the trivia questions were about this. NASA put out, this is not an actual video of the launch. This is a pretty little animation that NASA threw out. Orion is the spacecraft that's designed to shoot up to the moon, do a bunch of stuff for about a month. How many of you got that right? 25.5 days. Do a bunch of stuff for about a month. It's got a bunch of interesting payload, both science instruments and otherwise. That's going to give us a ton of information, and then yeah, hopefully come back. So Artemis launched, I say finally, because I presented this in the news in August. It was supposed to launch August 29th, and then it was supposed to launch September 2nd, and then it was supposed to launch September 5th, but it didn't, and we all know what that's like. Moving on. So Orion took a couple of really pretty pictures looking back at Earth. This is Orion right here. It's got this like outboard camera looking thing that, well, in this orientation is looking right back at Earth. Yeah, okay. So moving on to the actual science. More audience participation. Does anyone who's not named Caitlin Weber want to guess what the name of this guy is? This is not a live human. This is a mannequin.
Chad.
Manny.
Manny is the closest, actually. His name is Commander Moonikin Campos. Moonikin, like moon mannequin. Campos comes from Arturo Campos, who was an electrical engineer who facilitated the safe return of Apollo 13. So they gave him a nod by naming this mannequin after him. So basically, what is Orion doing? Why do we actually care, other than it's the first time that anything's been sent to the moon in a while? So there's a couple of these mannequins that are being sent up, which basically have a whole bunch of scientific instruments and new like test equipment and stuff that we're basically using to see how viable these new experimental technologies are in actual crewed spaceflight in the near future. So we'll get back to Commander Campos in a little bit. There's also these two other dummies who are not given as much personality. They're not even given legs. So anybody want to guess their names? Yeah, so the top one is Helga. I'm not making this up. It might be nice to note that the primary contributors to the Orion spaceflight are the United States, Israel, and Germany. So the Germans got their hands on that one. The bottom one here is named Zohar. Does anybody actually know what the Zohar is? What did you say, Justin? Do you want to embarrass yourself? Okay. All right. So the Zohar is actually a text from old Judaic mysticism of Kabbalah. It's interesting. It was actually one of the first books ever put in Greek alongside the original Gutenberg Bible. Look it up. It's cool. Zohar, Z-O-H-A-R. So yeah, so these two also have a bunch of scientific instruments in them, but they're designed to essentially have things that mimic the soft tissue and bones of real humans. And so if we do all this stuff and they come back and they're dead, then that means that this new equipment failed, unfortunately. Zohar down here is wearing the Astro Rad, which is this new, basically a vest, kind of like when you go and get X-rays done, you have to wear the big lead vest thing. This is basically designed to do the same thing. It's to protect you from harsh radiation from the sun, where you have no atmosphere on the moon. But yeah, so these two are cool. In addition, and this, I had so much fun writing these slides. So there's this thing that's called the official flight kit. And basically it's a box that they put a bunch of stuff in to fly it up and then bring it back down. It's not actually going to do anything while it's up there, but there's a lot of stuff that's in there. Things like what we'll get into, but a lot of it's for like education and outreach programs. If anybody's heard of like the moon trees from back in the day in the Apollo era. So in the Apollo era, they sent a bunch of seeds and stuff to the moon and back, and then planted them, and those are now known as moon trees. Basically, stuff like that, designed to test how biological life that has gone to space and back can grow. So yeah, what they're loading in here is a bunch of patches. We'll get to that. I want to play a game right now. I'm going to show you. This is you shouldn't be able to read this, but this is the full official flight kit. 3 pages long, publicly available. You can see everything that your tax dollars are going to throwing in space. There's so much stuff here. I'm going to pull out a couple of good ones. I hope that you can read this. Okay, so a wrapped pen, nib, and comic strip from Charles Schulz, the author of the Peanuts. Quantity 1. A Dead Sea Pebble. Quantity 1. 4 Lego minifigures. I see some whispering going on over there. Caitlin, no cheating. Would anybody like to guess their names? Anyone?
Are they all like your genders?
They are gender binary. Yes. There are two male and 2 female figurines.
Brittany, actually, Dawn, and Nikko.
Chad. So we have from left to right, we have Kyle, Julia, Sebastian, and Kate. I'm not making this up, sorry.
So
There was actually, I dug deeper into this than I should have. There was actually a nice article from Lego talking about these 4 and like how they're gonna get like a retirement ceremony when they come back. I'm not making this up. Yeah, Lego has actually had a partnership with NASA for the last like 30 years. And so there have been a lot of Lego figurines that have gone into space. Anyway, continuing on. Patches and name tag on Commander Moonpin campus, not in OFK. I just wanted to have something where you could see his name in print because it's ridiculous. But yeah, if we were to go back, he's got a whole bunch of patches and stuff on his uniform. Moving on. From Lockheed Martin, we have various US state flags, 52. But from NASA, we have various US state flags, 38. You know, I don't know who the holdouts were or who the extras were from Lockheed, but I'm just gonna blame everything on Indiana. And last on this list of bangers, we have Shaun the Sheep. Shaun the Sheep has had a partnership. Shaun the Sheep is from Wallace and Gromit, and Wallace and Gromit had a partnership with ESA for like a long time, and I don't know why, but I think it's hilarious. Okay, to finish off, if anybody actually remembers what I titled this segment in the news, I was talking about Snoopy. So there's also a little plush Snoopy who is who's going into Orion. Well, is currently in Orion. And you might ask, well, why Snoopy? Snoopy, this was incredible to me. Snoopy and the Peanuts have been connected to NASA and crewed space flight from the United States for quite a long time. Why? It was because Charles Schulz drew a bunch of stuff back in the 60s and the 70s of Snoopy on the moon, and it kind of just took off. This went so deep down the iceberg such that NASA nicknamed Apollo 10 a Snoopy. They nicknamed it Snoopy because it went to snoop out the moon so that Apollo 11 could land on it. I'm not making this up. So yeah, if anybody's wondering what the technical description of Snoopy is in the OFK, it is a Snoopy 0G indicator not in OFK from NASA headquarters. What does that mean? It means that they threw a Snoopy into the capsule and are gonna watch it bounce around when it gets to 0G. I think this is just wonderful. I have one more quiz question for the audience. So I mentioned the three primary contributors to this mission are the United States, Israel, and Germany. Would anybody like to guess how many total United States flags are in Orion? Not talking individual states, just the United States flag. 420. We have one call for 420. 17. 17 of 300. Anybody else?
10.
A 10. Well, Yaswant wins the Price is Right. It's 567 or more. There are some like weird unlisted things where it's just like flags. So yeah, who knows? There could be more, but at least 567 American flags. Would anybody like to guess how many Israeli flags there are? Two. There are 2 Israeli flags. All right. So yeah, we all know why. Because I actually, does anybody want to guess how many German flags there are?
6. 1 solid.
Yaswant's killing them. 0. There are 0 German flags, 567 American flags, 2 Israeli flags, scoreboard. So I hope you all enjoyed this. I really love this deep dive into what actually goes into a spacecraft alongside just the scientific instruments. Orion is pretty incredible. It's hopefully going to be a roadmap to a lot of extremely interesting things that come in the future, as far as the future of crewed spaceflight to the moon and beyond. So I will leave you with this very pretty animation that's in the news. Thank you very much.
Question for Nikko. I have one actually. What was written over Hipparchus's manuscript?
Yeah, okay, so the question was, what was written over Hipparchus's manuscript? I don't know what it's about. It was a text from like the 1600s that was by a guy named John Glynn, I think. Couldn't tell you what it was about. It was Christian in nature, hence why it's at the Museum of the Bible. Anything else? I thought that was an incredible story. If anybody wants to go look into that, well, either Artemis or the Hipparchus manuscript. Do I know where the moon trees are planted? There's like hundreds of thousands of them. So there.
Johnny,
yeah, so
They were afraid of the radiation from the moon, and they didn't want to enter anywhere. So like GMO things stay and everything is so
a lot of them were like given to school children, and then they were like, "Here, go plant things." They did. Final note: they did a similar thing in the early 2000s with basil seeds. This was a major like elementary school, middle school outreach program. They sent up like millions of basil seeds to the ISS for like a month or two, and then brought them back and then just distributed them to like tons of school districts across the United States. I planted some myself, and they actually had you do an experiment where you grow the space basil side by side with earthling basil, and you measure like the height, the size of the leaves, and all that stuff, and you can actually submit it to NASA. So it's like,
too many variables in that experiment.
listen, it's crowdsourcing, and it's great for 10-year-olds.
All right.
But I grew space basil and I've eaten space basil, so get wrecked, nerds.
Is that why you're like this?
Yes.
Well, let's give it for Nikko. Also, I just want to say real quickly, in fairness for why there's over 500 US flags, a lot of that stuff is stuff you just like give away to people, and then they can have in their office be like, look, everyone's flag that was in space. So that's the reason we're sending so many, so that 500 people can say, I will think go into space.
And 2 Israelis.
Yeah, and I guess right on German, because I was like, Germans don't care about that, so. Guess 0. What do we have next?
Burning questions panel. So if you're on the panel, please get up here. Bring a chair, probably. So now what we're gonna do is we're gonna give all of you a little opportunity to ask some people who are much smarter than me about some questions in astronomy that you might want to have answered. So we have John, who is a postdoc scientist working with Janelle Walsh on black holes. Nikko, working with Casey Papovich on very distant galaxies. And Passion Beta. Sylvie works also with Janelle Walsh on supermassive black holes. And Yaswant works on supernova with Peter Brown and Nick Sunset. So first give them a big round of applause for being up here. And if you have any questions, ask away. Any questions? Okay, we do have stock questions. So first off, what do astronomers mean by looking back in time? I think Nikko is probably the best suited person to answer this question.
Yeah.
Post back time. Oh, we're gonna break things. All right, so the question is why, what do we mean when we talk about looking back in time? So we already got a pretty good answer to this from Jacqueline. Basically, if you remember Jacqueline's slide where she had the Big Bang over here and the present day over here, given assumptions about the cosmology of the universe, basically the pathways to how the universe got to what it is today, we can say if we look in distance, something that is farther away, it's moving more quickly away from us than things that are around us. Jacqueline and me and other extragalactic astronomers call this redshift. So things that are further away are more red shifted. They're moving further, or they are moving more quickly away from us. And basically, looking back in time is essentially just looking farther away, because I'm pointing to nothing, I realize that, but in Jacqueline's picture, Big Bang over here, present day over here, the physical distance corresponds to the amount of time if you assume cosmology. Yaswant, sure.
I just want to add to, in more layman's terms, like the laymaners terms. I remember, okay, so this is like quick story time. No, like that was an excellent explanation, but like to dumb it down even more, if you will. So I was in class one time, it was like astronomy, like 200 or something. And the professor was like he asked something about this, like why do we look back in time? And it's essentially like, okay, I raised my hand as a little person, and I was like, it's because light is finite. And he was like, yes, that's right. Yeah, stellar moment to me. Okay, so light is finite. So essentially it takes also time for light to travel. So if you think about the light that comes from the sun, does anyone know how much time it takes for light? No astronomers, I'm so sorry, Lena, you counted by association. 8 minutes. 8 minutes. Okay, close enough. So like it takes some time, and that's like a certain distance. If you ask astronomers, it's 1 astronomical unit. So it takes time for that light to travel. So essentially we're like looking back in time. So if the sun exploded for no reason, because it can't for any reason right now, we wouldn't really understand, like not understand, but we wouldn't really realize it until 8 minutes later. So if we're looking at things that are like billions of light years away, it's going to take years for that light to get to us. So that's how I understand that in dumb terms. So.
No, that's about it. Yeah, speed of light is finite. It takes time for the light to reach us. And so if the object is a certain distance away, the light, it emits a photon. A photon will take some time to reach us. And so what we're seeing is just based on the distance, that's how long ago we're seeing this object. That's it. Yeah.
Cool, so now, are telescopes more sensitive than the human eye?
Yes, next question. Just kidding. Yes, if human eyes knew how to integrate and you could stare at something for as long as you wanted to, then no. And it depends on what you mean by sensitive.
What does integrate mean?
If you could sum things over time, which you can't do, like I can't stare at Vinny and then him move and I still see the picture of him there and while he's moving. So like I'm losing that information as soon as Vinny moves. If I could keep all of that information and stare at something, then it also depends on semantically what you mean by sensitive, but sure.
So if our eyes had shutters, we could leave them open. Is essentially what we mean.
Pretty much. Yeah.
I'll also add, I'll also add that we could make telescopes bigger than our eyes are, and so they have much better light collecting power in light buckets. You want to talk about light buckets?
No.
Telescopes are light buckets. Not all telescopes. A lot of telescopes are light buckets, and what we mean by that is kind of like Nikko was saying. You point a telescope at an object and just sit there with some filter over the telescope so that it only collects light of a certain set of wavelengths, and then it just counts up all that light and keeps adding it, and you can kind of like, after the fact, look at how much of the light was collected from whatever your telescope was looking at. It's not quite so easy to try to do something exactly like that with your eye. We don't store information quite as conveniently like that in our brains.
But semantics on the word sensitive, bigger lenses or mirrors or things can see things that are more closely separated. So if you mean sensitive as in collecting light, then no. Well, in the infinite limit of time, like if you stared at something for infinity, it's the same. Well, it depends on how long you integrate for. But if you're looking at two things that are very closely separated, it doesn't necessarily, this is why people have glasses. It doesn't necessarily care about, yeah, get right, Justin. It doesn't necessarily matter how long you look at the thing. If they're too close together, you can't tell what the two things are. So you have things like corrective lenses. Yeah. So the telescope size matters a lot depending on what you mean by sensitivity.
Justin, did you have a question?
Yeah.
What makes a supernova super? Yaswant?
Super cool.
It refers to the fact that it's about 1 million times brighter than a regular nova.
What's a regular nova?
No, brighter. Not better, brighter. Also brighter. Yeah, sure, better, sure. Yeah. It depends on what you study. So novas and supernovas are brilliant basic explosions. Supernovas are specifically explosion stars that end their lives. Novas, as we know of them now, are basically eruptions from stars, not stars dying, but maybe they have a big flare or something, or some sort of big outburst that gets a bright light explosion. And so we see that as this nova, which is basically just means new light. Is literally scientists long ago were just like, wow, this star is brighter than normal. There's a new light, it's a nova. And then like, hey, there's a really, really bright thing over here that wasn't there yesterday. That's super bright. That's a supernova. And it's just one of these naming conventions that have stuck over time. But yeah, so supernovas are called super because they're literally 1 million times brighter than regular novas. And regular novas are just stars that happen to be brighter than normal.
Can you tell us what we use them for? Like,
Supernova or nova? There's also kilonova, which is just.
I was gonna ask why a kilonova is a kilonova only 1,000 times bigger than a nova?
Brighter, yes, it's roughly 1,000 times brighter than a regular nova, so that's why it's called a kilonova. And a kilonova is two neutron stars colliding and exploding, and that explosion is called a kilonova.
Is there a meganova?
I think that's an AGN.
Is it?
Yes.
I think-
No, as far as we know, there's no observed meganova, and if they were, we would probably not be alive. That's how it works. Like mega is like millions. Yeah. Well, supernova is already a million times better than regular nova.
Wait, so a kilonova is 1,000 times than a supernova?
Than a regular nova. Kilonovas bigger than supernovas, yes. In theory, we've only seen like one of them and like barely, so.
What about superlumin and supernovae?
So yes, there are things called superluminous supernova, which are much more brighter than supernova, but like 100 times brighter than a regular supernova. They're not like. And those are just usually just really massive stars that are exploding, and more massive stars when they're massive explosion, basically. So. I don't want to go further because then I'd have to make a whole AoT talk. So.
Nice.
And that is all the questions that we have. Does anyone from the audience have something in particular that they'd like to ask? Yaswant has a question.
Yes, this is for the panel. What is your least favorite planet and why is it Mercury?
Okay, sure. My least favorite planet is all of the planets in the TRAPPIST system. For those of you who don't know, TRAPPIST is a red dwarf star around which were observed approximately, I think it's 7 planets that would nominally be in that star's habitable zone. In other words, at the right distance from that star, given that star's temperature, where liquid water could hypothetically exist on the surface of those planets. And the reason this is, these are all my least favorite planets, is when these were kind of like first coming out and being observed and being announced, everyone was like, oh, look, 7 perfect planets where there's totally going to be perfect conditions for life. And then everyone said, wait a second, it's around a terrible star that's going to be, red dwarf stars tend to flare a lot and not be very stable. And so most of those planets, we think, if not all of them, are actually not going to be remotely habitable. And therefore, they are my least favorite planets.
Mine is Earth because I'm on it right now. Mine is also an exoplanet that's called Beta Pit. And the only reason is because my office mate never shuts up about it.
I'm gonna tell you what my not favorite planet is. Wait, that was the question. Sorry, well, my not favorite planet is Pluto. Let's talk about Pluto for a second. That's what I'm saying. The Pluto fans, if you would wear a t-shirt that says Pluto is a planet, please walk away right now. Thank you. It's not even gonna work. Yes, thank you. So I'm just gonna say that's that's my not favorite planet. It's okay. Don't think about it too much. Thank you to the people that decided, what was it, like early 2000s, 2006 to be exact, what it required to be a planet. Let's trust the scientific astronomers. And Pluto's not it didn't make the cut, literally. So that's my answer. Earth is pretty cool, and Jupiter is probably next.
I would like to note that Pluto was demoted from its planet status in 2006, which is only 1 year before the original planned launch date of JWST. So Pluto was demoted and everything fell apart. So we love Pluto.
That's all.
What's your least favorite apple? Yeah.
I don't know that many planets, so, I mean, other than the 9, 8, like, the 8 in our solar system, other than that, I don't know that many ISO planets. Why not Venus? Just seems really hot there.
Venus.
Wow, hot take.
Well, it's Mercury the right answer.
Yeah.
Mercury sucks. It's smaller than like 3 of the moons of the solar system. It's just like there. It's not doing anything. It's just lucky to be alive.
Okay, what's your favorite galaxy type? All of them. Go. I'm not talking about like an NGC. I'm talking about like a galaxy type. Class.
So when I started, my answer would have been these things called extreme emission line galaxies. Because they're super young, super starbursty things that we don't understand super well and might be kind of like undergoing their first major sort of burst of star formation. And we think a lot of star forming galaxies might actually grow that way by having these sudden bursts of star formation where they throw out very big extreme emission lines. But now I'm a boring old black hole person, and therefore my favorite types of galaxies are boring elliptical galaxies, which have very massive black holes in them, because they have very cool black holes in them. That's why I like them.
I'm gonna basically take John's, what would have been his answer, but give him a more specific subtype and say, right now, my favorite type of galaxies are things that we call pop 3 galaxies, which are galaxies that were formed from the very first generation of stars, way back in the early universe. These are my favorite because we don't know anything about them, like literally nothing about them. So lots of science to be done in the coming decades.
Okay. I know I asked this question, but like, you know how you love your grandpa?
No.
Grandma, grandparents, reverends, never mind. Okay, there we go. Elliptical galaxies. They carry history. They're the oldest things in the universe. I mean, globular clusters, like, okay, they're all right, but elliptical galaxies, they really just had so much like rich history, and if you want to talk more about that, you can later with me. But I just think they're essentially like ancient and carry a lot of history and overlooked and not boring. IMO. So that's my answer.
I guess low metallicity star forming galaxies, because that's where the fun supernova are.
Oh.
Any questions from the audience?
You had to pick one off the Hubble tuning fork, which what type would it be?
I see you're like getting rid of something.
Of the favorite galaxies.
Oh, our favorites.
Think that Hubble tuning fork.
Yeah.
I don't know anything.
So the Hubble tuning fork is because Hubble was very, 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 very wrong about things. He thought he knew what was going on. If we broadly classify a bunch of galaxies, I'm pointing to the screen that there's something there. Oh, we need to. If we classify galaxies, we broadly classify them into things that are spirally, things that, and those are usually blue forming a bunch of stars, things that are kind of like a circular blob, a spherical blob. Those are what we call elliptical galaxies, red and dead. They're not forming stars. Jacqueline kind of talked about a bunch of those earlier. And then things that are irregular, probably very star forming, and they don't really fit into any of these categories. Broadly, those irregular things are very star forming, very young galaxies generally. But Hubble thought, when he started seeing these sort of like dichotomy of galaxy types, he thought, okay, you know, maybe galaxies start out as these faceless reddish orbs and eventually evolve to have these beautiful spiral arms. And so he made a tuning fork where he put a line of kind of like those reddish orbs going from, I think it goes from spherical to less spherical, or is it spherical, yeah, okay, from spherical to get more and more elliptical until it gets almost disc shaped, and then it splits off into this tuning fork shape. So two sort of branches, one branch and both branches have spiral galaxies on them. One of those branches of spiral galaxies has a bar on, like, kind of through the middle. And the basic idea, he thought, was that you start at one end and kind of go along as the galaxy gets older and older, and then you pick one of those one of those tuning fork tracks, and you travel along there, and that's how galaxies form and evolve. We now know that's complete bullshit. That is not what happens. If anything, it more goes the reverse direction, where you have these irregular galaxies that may or may not ever form spirals, and then eventually merge and age and die off and become those elliptical galaxies that we see on the left-hand side of the tuning fork. My favorite galaxy on the Hubble tuning fork is an S0 galaxy. So that's kind of like right at the merging point. It's called lenticular. It's sort of disky, but it doesn't have any spiral features, and it's pretty reddish, sort of. Because the particular galaxies that I study are probably lenticular galaxies.
I mean, I mostly study AGN, which are point sources, so I don't know what this is. What I mean by point source basically just means if you look at it, it just looks like a dot. So none of what John just said applies.
A real question. So 10% of galaxies are like AGN, and we've found evidence, right, between you and I at least, that even like the most massive galaxies contain AGN. Does that, like, you can still see AGN within galaxies in the nearby universe, so like within like redshift of 1, but you just don't, you're saying you just don't study those. I mean, there's still point sources, but like there are different types of galaxies that contain AGN.
No, we resolved. There are lots of different types of AGN. So there are AGN that are not. Oh yeah. Black holes that are resolved. Yes. Yeah.
Oh, we're not talking about black.
But no, like just AGN wise, you see those in all types of galaxies. Yeah.
Are you like the source itself?
I'm gonna go ahead and cut us off because it's 9 o'clock.
I just wanted to say that my favorite time is also a 0. That's all.
You just look weird, man. I don't know what to tell you.
There's so much that we don't know about the S0 galaxies that we're still trying to understand beyond like what is the supermassive black hole and galaxy war relations. Like what about the structure? Anyway, that's all.
All right, let's have a big round of applause for our panel speakers in that. And now I think we're just gonna wrap up with trivia answers. So for the, I meant to have the beautiful. So question 1 was, who was the first person in space? And the answer is Yuri Gagarin. Question 2, how long does it take Orion's abort launch system to accelerate to 500 miles an hour? And the answer is 2 seconds. Oh, wow, that's really quick. Yeah. Question 3, how many human spaceflight launches have there been? And the answer is 366. It's a whole lot. Question 4, what year did humans first land on the moon? 1969, nice. What were the first things to orbit the moon? And it is 2 Russian forces. How long will the Artemis 1 mission be? Nikko answered this question already. It will be 25.5 days. And then question 7, how much will the Earth's atmosphere slow Orion down during re-entry? 24,000 miles an hour. How many parachutes does Orion have? 11. I'll just make one big one. The first moon landing missed the landing site by 4 miles. True or false? True. And the last question, What year was the last crewed mission to the moon? And the answer is 1972. So a while ago. And the winner is Mahab.
Oh, is that me?
Yes.
So come see Justin on the show, and you can get yourself a shirt or whatever you want, or any of the free swag at the table. And now we're gonna really quickly go over announcements again. So we just finished trivia, but make sure to scan our QR code to follow us on social media. Tell anyone more about AOT. Follow us on social media, you get a free AOT sticker. Support the Grand Stafford, make sure to tip your barcodes before you go home tonight. Support AOT, donate us on our donation box or on Venmo. $50 gets you t-shirts, $10 gets you a mug, or you can win the trivia and get cheaper that way. Our next event is gonna be December 21st, and that's a winter solstice. That's the third Wednesday of December. We are sponsored by Science Socks at sciencesocks.co. Check out their awesome swag. I'm definitely gonna be looking up there later tonight. Hey, Christmas is coming up, Hanukkah is coming up, the holidays are coming up. Get yourself some stocking stuffers, you know, get yourself some stockings to stuff. Make sure you talk to your local astronomers with the glow sticks if you have any questions that weren't answered. And thank you so much for coming out here tonight. That's the end of our show. Thank you so much.
Thank you for coming. Thank you for sitting down. Good luck.